Did I hit it? All right, this is Mr. Hendrickson again. We're trying a little experiment. I'm trying to use the camera that's on the computer, and it's a little awkward, but we're going to go with it. This is lesson 9.5, graphing quadratics from standard form. Up to this point, we've done vertex form and we've done factored form. We're now going to look at standard form, which it shows right here. Standard form is where it's f of x equals ax squared plus bx plus c. So they kind of put it in the normal way we usually see a quadratic equation. It's always going to give us a parabola. The parent function is up here where it's just y equals x squared. In this case, the a equals 1 because it's 1x squared. There is no b, so b is 0. And there's no c there, so c would be 0. So those are the a, b, and c. And that's important when we try to find a couple of pieces that are important on this function. For today, we're only going to focus on the axis of symmetry, the y-intercept, and the vertex. So the a, b, and c will come in where when we try to find the axis of symmetry, we use the b and the a from this formula. So we have to identify those because the formula for axis of symmetry, and it's an equation, so you have to write x equals minus b over 2 times a. So we figure those a, b, and c in the beginning, and we get those. The y-intercept is nice and easy. It's just the c value, and we should always write it as y equals c. And if there is no c, like this in this case, you just write y equals 0. So the y-intercept would be 0. For the first couple of examples, it's already given us the graph here, so we don't have to do as much work on this. We can find the vertex just by looking at the picture. You find the vertex, it's down at the bottom here on this one. So I would just put vertex, and we give the point for that. It's over 2, down 2, so the vertex is just 2, negative 2. The equation of the axis of symmetry. Now, normally I would do the minus b over 2a if I don't have a formula, but I can see the axis of symmetry in the middle. So if I have the graph, the axis is just the equation. It's always an equation, and it's x equals that x value, which is 2. And for the y-intercept, in this, again, if I have the graph, I can just see the point where it hits the y line, and the y-intercept is just y equals whatever that value is, in which case positive 2. So when I have the graph, I can see all these points and lines, and I can just find them from the graph. So another example next to it here, again, the vertex is the point at the top. So my vertex is the point over 2 up 4, so 2, 4. My axis of symmetry is the line that's in the middle of that. So it's just the x equals, it's always an equation for the axis. X equals the x value, which is 2. And the y-intercept is just where does this hit the y line? Sometimes the arrow is a little bit tricky to see, but there is going to be at y equals negative 4. So that's how I do the first two. You can do the next two. That's the examples. You can do the exercises on that. For the other page, I'm going to flip pages here, and hopefully the camera's lined up for us here. In this case, we're going to have the equations rather than the picture. So if you want to go into Desmos and kind of like we did today, if it worked out okay, you can fill this in, except it's in standard form, so it might not work as good. We're going to just use the equation that we had for the axis of symmetry. So the axis of symmetry, and I'm just going to write the equation at the top here. It's from the other page. Oops, sorry. Let's rewrite it as x equals minus b over 2a. So I want to identify my a and my b. So in this first equation, when I go to do these problems, I want to make sure I figure out that a equals 2, b equals 4, and c equals negative 3. Now for this equation, I don't use the c, but it does come up in some later stuff. And right now we're just doing the beginning, but I want you to get used to identifying a, b, and c. So the first one I'm going to find is the axis of symmetry. And for the axis, I just write the formula x equals minus the b. So that b is positive, I make this a minus 4. If b were negative, I would make it a positive because you switch the signs. And then on the bottom, you do 2 times a. If a is 2, I'm going to do 2 times 2, which gives me negative 4 over 4, which is negative 1. So my equation is x equals negative 1. For the vertex, I need to take that x value and plug it into the equation. So for the vertex, I'm going to write y equals 2 times negative 1 squared plus 4 times negative 1 minus 3. And I do the math on this. So it's 2, negative 1 squared is positive 1. So it's 2 times 1 is 2. 4 times negative 1 is minus 4. And then minus 3. 2 minus 4 is negative 2. Minus 3 is negative 5. So the y value is negative 5. So my vertex becomes the point where I chose my x from here, which was negative 1. And the y is negative 5. The y-intercept is the easy one. Y equals c. So I look and see what I had for my c value, and you write y equals negative 3. So there's my three things that you have to find. The axis of symmetry, which is the x equals negative 1. The vertex, you plug that x value in and do the math to find the point. You get the x and the y. The y-intercept is nice and easy. It's just the c value. So I'll go through another example here for example B. And I identify A, B, and C. And those are just the numbers in front of the x squared, the x, and the number by itself. So for my axis of symmetry, x equals minus b over 2a. In this case, it's going to be minus 6. And 2 times negative 1 is negative 2. Or I get x equals 3. For the vertex, I plug that 3 into the equation. So it's minus 3 squared. And this is important when there's a minus there. It's the 3 that's squared, not negative 3. The x gets squared, but the minus goes after. Plus 6 times 3 plus 4. So 3 squared is 9. The minus comes after that, so it's minus 9. It doesn't become negative 3 squared. Be careful there. The 6 and 3, that makes 18, and it's positive, and then plus 4. So minus 9 plus 18 is 9, plus 4 is 13. So the point becomes the x value that we just had, and then the y value, and that'll be the vertex. And again, for the y-intercept, easy part, y equals c, so y equals 4. And the reason it's just the c, because at the y-intercept, you know that x equals 0, so the other parts will all become zeros, so the only part left is whatever's left on the c part. So that's why that comes out fairly easy to figure out. All right. Third example. This one does not have an x term. Slide it which way? Forward. Okay, so hopefully this comes out. A is going to be 1, because that's what's in front of the x squared. There is no x term, so I want to make sure I write that b in this case equals 0, and the c is negative 9, which makes the axis formula a little bit easier, actually, because if x equals minus b over 2a, I end up with 0 on top. And the 2a is 2, but that just means x equals 0 is my axis of symmetry. It also makes the vertex a little bit easier, because if x is 0, y equals 0 squared minus 9, which is just negative 9. So the point is 0, negative 9, and the y-intercept is also just y equals negative 9. So that's how you do today's lesson. We're just looking at the main points are the axis of symmetry, which is x equals minus b over 2a, the vertex, which is the point, the top, the max or the min on the parabola, and the y-intercept is where it crosses the y-axis. If you have an equation, you want to find the axis of symmetry first, then the vertex, and then the y-intercept. If you have the graph, it's usually a little bit easier. So you have 3 examples to finish for that, and 2 of the graph ones. Good luck.